Welcome. This is Coach Dorf. We're in Appendix E on sigma notation, and we're going to look at the following homework-like example that involves telescoping sums. So let's write down what the sum is. We have the sum is I equals 1 to n of I to the fourth minus I minus 1 to the fourth. And let's write down some terms. And when we're doing telescoping sums, we'll write down several different terms and we'll try to find a pattern of things that cancel out. So the first term is I equals 1. That's going to give me 1 to the fourth minus 1 minus 1 to the fourth. Now I do the next term. I have I equals 2. So I have 2 to the fourth minus 2 minus 1 to the fourth. Let's do the third term. So that's I equals 3. So I have 3 to the fourth minus 3 minus 1 to the fourth. And we'll do one more term in this order. We'll do I equals 4. So I have 4 to the fourth minus 4 minus 1 to the fourth. And I think you can see the pattern there, what's happening. All right, now we're going to keep doing this pattern until we get to the very end. So the second to the last term is n, so the second to the last one would be n minus 1. So let's put in n minus 1 here. So I equals n minus 1, we're going to get n minus 1 to the fourth minus n minus 1 minus 1 to the fourth. And then the last term would be I equals n, so I get n to the fourth minus n minus 1 to the fourth. All right, now let's take this and simplify the second part there where we have a parentheses. So I have, in the first one, I have 1 to the fourth minus 0 to the fourth. The next term I have 2 to the fourth minus 1 to the fourth plus 3 to the fourth minus 2 to the fourth. Again, the 2 is going to be coming from this part right here where I have 3 minus 1. That's where that 2 comes from. Then I have 4 to the fourth minus 3 to the fourth. And then when I get to the end, I've got n minus 1 to the fourth minus n minus 2 to the fourth plus n to the fourth minus n minus 1 to the fourth. Now let's look at what cancels. What do we have that's the same? Well, we notice that this first term, I to the fourth, cancels out with this minus I to the fourth in the second square bracket. And then the first term, 2 to the fourth, cancels out with the second term in the next bracket. The 3 to the fourth cancels out with a minus 3 to the fourth in the next one. So every time what's happening is the first term in the bracket cancels out with the second term in the next bracket. So even though we don't have it shown here, this 4 to the fourth is going to cancel out with a term that's going to come in the next bracket here. All right. Likewise, we could think about it that the second term cancels out with something in the first term. The second term in a bracket cancels out with the first term in the previous bracket. So let me show this in blue. So for example, this minus 1 to the fourth that I just circled in blue cancels out with the 1 to the fourth that comes before it. The 2 to the fourth here in this third bracket cancels out with this 2 to the fourth that comes before it. So everything that is the second term cancels with something that comes before it. All right, so if we continue with this pattern here, if we look at the last two brackets here where we have these n's in here, this second term minus n minus 2 to the fourth is going to cancel out with something that comes before it. All right, just like the other ones did. Likewise, this minus n minus 1 to the fourth cancels out with something that comes before it, and that's right here. Now, does this n to the fourth at the very end cancel out? Let me write that in green here. Does this n to the fourth cancel out with anything? No, because the first term always cancels with something that comes in the bracket after it, but there's nothing after it. So that's going to stay. How about this 0 to the fourth? Does it cancel out with anything? No, because the second term always cancels out with something that's in a square bracket before it, but there's no square bracket before that. So when I do this, I'm going to end up with minus 0 to the fourth plus to the fourth. Everything else cancels out, and I end up with a final answer. Since 0 to the fourth is 0, I end up with a final answer of n to the fourth. That's what that all equals. Now, why is this called a telescoping sum? Well, this harpens back to the idea of a collapsing telescope. And a long time ago, a collapsing telescope might be a telescope that looks something like this. You have one piece, and then you have another piece that's just a little bit larger than that. and another one that's a little bit larger than that, and one that's a little bit larger than that. And that you would use that, and this would have a little eyepiece at the end that you would look into. And that would be really long, and by doing it that way, you get a stronger magnification. But you can collapse this into a smaller size so it's more portable. So these middle sections all collapse into each other, and so that when it collapses, you've got that big last piece on the right, and then you've just got the eyepiece right there. All right. And so what's happening here is all the middle terms are disappearing inside the other one. So you only have the first and the last. And that's what's happening with these sums, right? What do we end up with this in the sums? We end up with something in the first term and something in the last term, because everything else collapsed out by canceling. That's why these are called a telescoping sum. Hope that helps.